In this video, we're going to be exploring the area of trapezoids. So first, some vocabulary. Grandma's going to help us out here. Grandma loves playing on the playground. The parallel sides of a trapezoid, and we will later in the school year get more in depth into the properties of our quadrilaterals in general, but trapezoids have, by definition, one pair of parallel sides, and typically we can see that they're parallel by these parallel markings. But our parallel sides are referred to as bases. Just like triangles have a base and a height, trapezoids have two bases. And these two bases can be signified by B sub 1 and B sub 2 as your two bases, and it doesn't matter which base is shorter and which base is longer. So don't think that just because this base is shorter that it should be base 1, or don't think because this is the top base, if you will, that this should be referred to as base 1. The non-parallel sides, so you're going to have two opposite sides that are not parallel, and they are referred to as legs. Just like in a right triangle, you have a hypotenuse, and the two sides that are adjacent to the right angle are referred to as the legs. And then the perpendicular distance between your bases is the height. So just like the base and the height of a triangle need to be perpendicular and make a 90-degree angle, well, we will also have a height that's perpendicular not only to one base, but technically the other base as well. So in this picture, I really should have a second 90-degree angle right up here. But just know that the height doesn't have to be over here on the left. I could draw in the height over here on the right side and draw in some 90-degree angles to touch both bases. But you could technically also draw the height in the middle. It doesn't have to be in the middle. It could be somewhere over here, as long as it is perpendicular to both bases. So bases, parallel sides, legs, not parallel sides. The perpendicular distance between the bases is our height. Now, we're first going to just explore in general, how could we find the area of a trapezoid, of any trapezoid? And so here's what I want you guys to really think about, is what shapes could we break down a trapezoid into? And so if you draw in the heights, let's say over here on the left side and over here on the right side, we can already start to see some smaller shapes that we could explore. So I can see we've got a triangle on this end, we got a triangle on this end, and we've got a rectangle in the middle. So here's what I want you guys to first consider, is what if we took this rectangle and we pulled it out of the trapezoid? And then you might go, okay, we got a rectangle and we got two triangles. But now I'm going to push you a little bit more and say, don't think of these as two separate triangles. What if we were to squeeze these two triangles together so that they really make one triangle? And so how I think about trapezoids is that I really have one triangle plus I have a rectangle. And sometimes that rectangle might be a square, but it's always at least a rectangle. Now, let me go back to this point here. I'm really saying the height is 12, which means the height is also 12 over here. So whenever I push those triangles together, I'm really overlapping this height with this height, which is the same number. All right? So if I were to take this out again, we've got a height of 12 for my rectangle, and I'm going to use this base of 10 that I pulled out. So the area of this rectangle, base times height, would be 120. Now, if I think about these two triangles that were left over, and if I were to push them together, I might be tempted to say that the base of the triangle down here, if I don't watch out with what I'm doing, I might think the base is 22. But what was the base? This 22 really represented the base of the rectangle, and it also represents the two bases of those smaller triangles. So now let me go back to this point. So the 22 is not the base of the triangle, but how much of that 22 did I eliminate right here when I pulled the rectangle out? And we really got rid of 10, right? Because this bottom part's 10, just like the top's 10. So that means that there's only 12 of that 22 left. And so when I push together those two triangular pieces, now that 12 really represents these two pieces. And so that's really the base of the triangle. Now, can I assume in any way that, well, this must be 6 and this must be 6 because this whole thing's 12? And no, not necessarily. I can't just assume that. Now, the area of this overall triangle, we could say is 1/2 base, this 12, times the height, which we were given as 12, and there's 72 of area. So now if I take my triangle plus my rectangle and think about it all together as the trapezoid, then the area would be 192 units squared. So in terms of the area of a trapezoid, there is a formula that you will commonly find in textbooks, but I don't like to focus on formulas that students may not necessarily grasp and understand. And I could illustrate why the formula works the way it does, but to me it's going to be just simpler for you to think about a trapezoid as two smaller, simpler shapes. So the area of the trapezoid, again, I would just think of as one rectangle plus, and again, don't think of it as two separate triangles, but push those two triangles together into one triangle. So again, we might need to draw in another height over here, and so here's our one rectangle in the middle, and take these two triangular ends, and again, think about it as just one triangle. Now, the base of this triangle will always end up being the difference of your two bases, right? Because you're going to have to take away, let me get my eraser here. This piece that's down here is going to represent the other base. So how much is left over for these two pieces together? Well, that would just be the difference of the two bases, the smaller base taken away from the larger base. So the base of your triangle is going to be this, if you want to think of it that way. So if you want to come up with your own formula, or if you want to take a look at the textbook formula, you can use that, but I would just highly encourage you to think of it as a rectangle and a triangle's worth of area. So the first real example we'll explore here. I'm going to need to split this thing up, and so let me draw in a height down here that's perpendicular to this base, and is also perpendicular to this base of 8 up here. And I can already see that this isn't just any kind of special rectangle, it is a square in the end. So this will have an area of 8 times 8, which is 64. So there's part of my trapezoid area. But now I need to focus on this triangular end. And at first glance, I might first recognize, well, this would be the height and this would be the base, but it doesn't look like I'm initially given either of those two values. But you do know the height, because the height is also 8, just like the left side of my square is 8, so is the right side of my square. And so now we need to consider, well, what is the base of the square down here? And so again, this is where my two bases of my trapezoid come into play. All of this down here is 14, and this up here is 8. So that means the bottom part of my square from here to here is 8. So how much is left over of this 14 if I take away this 8? And that leaves me with 6. So now the area of this triangle is going to be 1/2 base times height, 1/2 6 times 8, which is going to give me an area of 24. And so if I take the 24 and the 64 and combine them together, that'll give me the whole trapezoid, which is 88 units squared of area. Not too bad, right? Hopefully. The second example, we're going to need to draw in two heights to split up. In the first example, we only really had one end that was a triangle, but in this example, we're going to end up having the two ends that are triangles. So I'm going to draw in some 90-degree angles, so I know my height is perpendicular to my bases. And so if we first focus on this rectangle, I can tell the rectangle is going to have a base of 12, but the height, we don't know. And even if we look at the two triangle pieces, we need to know the heights for it as well. So first we need to discuss, how do we get those height values? So let me just put h's right here and here. And so we're going to have to come over here to our triangle with the 60-degree angle in it. And here's where we have two options. Since we have a right triangle, thanks to our height being perpendicular to our base, we could use some trig here. We could use some sine, cosine, tangent. We just got to figure out which ratio works in this particular setup. Or technically this is a 30, 60, 90 right triangle. So we could use our 30, 60, 90 patterns. So I'm going to show you both ways here. And first I'm just going to start with the trig route, because at this point you guys should be pretty comfortable with using trig. So using my 60-degree angle, the height is the opposite side and the 14 is the hypotenuse. So opposite and hypotenuse would allow me to use the sine ratio. So the sine of 60 degrees equals the opposite, h, over hypotenuse 14. And to solve for the height, I would simply just multiply the 14 over to the other side. And so in my calculator, I would need to come up with an approximate value. And I'm going to go to 2 decimal places here. And so if I type in 14 times sine 60, I get 12.12. So now I know the height of not only the rectangle's 12.12, but also of my triangles are 12.12. And so now let's go ahead and solve for the area overall, and then I'll go back and we'll talk about the 30, 60, 90 pattern, and we'll redo the area that way. So the area of the rectangle, so usually I'll put a little subscript RECT for rectangle, or I could even, too far, say the area and just draw in a little baby rectangle down here, would be base times height, which is the 12 and the 12.12. And so that's going to give me 145.44. Now that takes care of the middle part of my trapezoid. But now I got to consider I have 2 triangular ends. But again, don't worry about finding the area of each individual triangle, because both of these triangles share a common height. So think about taking this triangle and taking this triangle and just pushing them together. So imagine this scenario. And again, we know this height in the middle, this is 12.12. And so the base would really be the top side up here. So imagine this triangle is just upside down. And so if we consider the rectangle, this had a base of 12, which means from here to here is 12. So how much of this 20 is left over for these 2 pieces together? So if we take the 12 away from the 20, that means this has an overall base of 8, all the way from here to here. Now, do we need to know how much of the 8 this piece is and how much of the 8 this piece is? Absolutely not. You're just going to be making more work than you really need to do. So now if we've got the area of the triangle is 1/2 8 times 12.12, now we're going to get what? 48.48 for the area of the triangle. And now we can take our 2 pieces, here's the rectangle area, here's the triangle area, and let's combine them now into an overall area for the trapezoid. And so if I add those together, I'm going to get 193.92 units squared. And so there's the approximate area, because we used trig and we got an approximate height. We had to round this number. So I would absolutely take this for 100% credit if you got me 193.92, or even if you said 193.9. If you went to the nearest 10th in the end, that's fine. So now I'm going to backtrack. So if you still are writing, you might want to pause the video so that you can get all this written down, because I'm going to backtrack here in just a second. So now I'm going to go all the way back to where we got to the point that we used sine to figure out the height. And now I'm going to say, what if we didn't use sine, but we used the 30, 60, 90 pattern to get the height instead? So we are almost there. Too much, way too much. Whoa, way too far. Way too far. Oh my gosh, what is going on here? Apparently I pressed the button way too many times. Okay, perfect. So now let's call this H. And again, we're going to focus on this being a 30, 60, 90. We know we've got a 60 and a 90, so the third angle has to be 30. So now if I were to use my 30, 60, 90 pattern values, the side opposite the 30, this is x from here to here. The side opposite the 60, the height, that's my x root 3 side. And the hypotenuse is the 2x side. Well, what's the one side in the pattern that I know? I know the 2x side is 14. So if 2x is equal to 14, then x is 7. So I know this piece up here is 7, but we really don't need to know what it is. But we do know that the height is 7 root 3. And guess what 7 root 3 is approximately as a decimal? 12.12. So now using the height not as 12.12 but as 7 root 3, the area of the rectangle is going to be base 12 times height 7 root 3, and I can multiply the 12 and the 7 and get 84 root 3. And then again, consider the triangle ends getting pushed together. This height is 7 root 3, and still this base overall is 8. Now we do know that from here to here was 7, which means from here to here is 1, but again, who cares? We need the overall base of this big triangle, and it's 8. That was the difference of our two bases. So now the area of this triangle is 1/2 base 8 times height 7 root 3. And so then 1/2 times 8 times 7 is 28 root 3. And so if I've got 84 root 3 for the rectangle and 28 root 3 for the triangle altogether, adding those, since both of these are root 3 numbers, I get a total area of 112 root 3 for the trapezoid. And guess what 112 root 3 comes out to be as an approximate decimal? You guessed it, 193.92. And again, either one of these answers is completely acceptable. The pattern route, as long as you know the pattern, will take less time to do. But if you're not comfortable with the pattern, don't be afraid to use sine, cosine, tangent. It's absolutely fine that you do it that way. All right, the last one here, I'm going to call this a pause and you try problem. So if you want to pause the video and try it on your own and then watch my solution, you can do that. Okay, so if you want to pause and try the problem out, and then you can watch. Otherwise, if you don't want to try it on your own and you just want to see a third example, then here we go. So let me move this out of the way. And again, if you want to pause, this is now the time to pause. So in this problem, I'm going to drop down not just one height, but I will need a second height over here. And so here's my rectangle in the middle. And again, later on, we'll push these two triangles together. So the base of my rectangle is not the 14, but it's this 10. Really, the shorter base is always going to be the base of your rectangle. All right, so I need to know the height. And the height I drew in two places, here and here. Now, I'm not going to be able to do much down here on this right end. And so you just need to know that I can't assume that this piece is 4 just like this piece is 4. I can't make that assumption. And I can't assume that this is a 30-degree angle just like this left end is a 30-degree angle. You can't make that assumption. So we're going to have to start down here. And again, you could go one of two ways here. This ends up being a 30, 60, 90 triangle. So you could use the 30, 60, 90 pattern. Or you could use trig. You could set up sine, cosine, tangent. So I'm going to show you both ways. So if I were to use the patterns, the side opposite the 30, this is the x side. The side opposite the 60, which would just be this part, this is x root 3, and the hypotenuse is 2x. And notice I know the 2x side. 2x is 4, which means x is 2. So I know x is 2, and x is not only 2, but x is my height. So I know the height of this trapezoid is 2. Now, this piece down here ends up being 2 root 3, which you can't assume that down here is also 2 root 3. And I'll tell you right now, it's not 2 root 3. But again, do we really need to know how much this piece is? No, we don't need to know, and it's just going to cause more headaches than it's really worth. So just leave it alone. Who cares that it's 2 root 3? So now let's focus on this rectangle. The area of the rectangle is going to be base of 10, height of 2. So it's got an area of 20. And then again, let's take these two triangle pieces and let's stick them back to back. Where are we at here? Oh, there we go. So we know the height's 2. And what is this overall base going to be? Well, if the 10 is the shorter base, then this is also 10. And take that away from the 14 that's all the way across the bottom here, and that's going to leave me with the leftover 4. So now the area of this triangle is going to be 1/2 base times height, which is going to give me an area of 4. And if I add together my 20 and the 4, then the overall area of the trapezoid is 24 units squared. Now I will backtrack to the triangle because I said we could also do this with trig. So let me just show you real quick the trig setup. So if I wanted to use the 30-degree angle, the h over here is the opposite side. The 4 is the hypotenuse. So opposite hypotenuse, this would be a sine setup problem. So if I had sine of 30 degrees equals opposite h over hypotenuse 4, I can multiply the 4 over to the other side to the sine of 30 degrees. And if I type this into my calculator, 4 times sine of 30, it comes out to be exactly 2. And so it's the same height that we got with the 30, 60, 90 pattern. And so from there, you could carry out the area of the triangle the same way that we did it when we used the pattern. And so that is all for this particular video, focusing on area of trapezoids.